Hey, what's up guys? Finally, I'm back with a new tutorial and today I'm going to show you how you can create this raspberry. This approach is different from the one that Entagma posted, so they also have a tutorial on a raspberry, but mine takes a different approach. I use a Vellum simulation and together with some setup you can also tweak parameters like how many little berries the big raspberry is made of. And first off, we're going to start with a base shape. So we want to get this shape. And to do that, I created a line and I counted the number of rows actual raspberry has. So in this case, it's 8. And then I also added the curve view attribute and I copied circles onto there. Using the curve view attribute, I created the p-scale for the circles. So with that, you can also, if you remap that, you can create this shape of the raspberry, and you can also modify that. So if I change it, the raspberry gets a different shape. For example, you can make it bigger at the top if you want, but mine is here for this classical raspberry shape. And after that, we go into a for loop where I use the detail attribute, which is created with this meta import node, to first of all resample all of them, and so that depending on how big the circles are, they have a certain amount of points. So I use a length here so that bigger circles have more points. Actually, let's look at it like this. And I fuse them as well as offset them depending on the detail attribute as well, so that every single one is rotate a little bit so that they are not exactly above each other like this one. As you can see, all the points are right above each other, as well as they all have the same amount of points. But that is problematic because, of course, at larger rings, the berry has more of these little ones. So that's why we do that, and at the end we end up with this. So at the bottom here only 6, and at the bigger ones a lot more, as well as they're slightly offset. So after that, we create the polyframe and noise it using a simple attribute noise in the P attribute. Nothing special here, just to create a bit more organic shape. And then we copy a sphere onto each of the points. Let's turn on the points here. And together with first of all, this is the one I point deformed later. So these ones are subdivided spheres with squares. But for the simulation, we want triangles. So that's why we do this copying 2 times. This time we use it for, this one we use for simulation, also without a UV attribute, and this one with a UV attribute we use finally to render. But let's look at it after the simulation. First we start with the simulation. We create the spheres and copy them to the points. It's important that they are smaller at the beginning, because we're gonna use the inflation to create this shape at the end where all the little berries are pushing against each other. So first we put on a vellum cloth, just a simple vellum cloth, nothing special here. I tweaked the parameters a little bit, but not a lot. And I reduced the stiffness, I think, a lot to create easier inflation. Then we create the pressure. And as you can see, I cranked it up a lot. So that we only need to simulate a few frames. And first of all, I wanted to connect all of them with constraints so that they stay together when they're pushed, they can't be pushed apart too far. But I realized I don't even need that. So you can just create the spheres and then use the speed of the inflation to create the collision instead of connecting them with constraints. In a second, you'll see what I mean. So if we go back to the start and we highlight the simulation, the solver. let's do that. And if I'm correct, I didn't change anything in here yet. And if we simulate now, you can see it takes a second, but they all blow up. And they naturally collide with each other. You have to stop it, of course. This one is too far. But if you go back a little bit, you see that they all really nicely create this collision shape. So if we can check which frame is the closest and still works, this one looks pretty good. And as you can see, they all collide with each other. Like naturally, the berry grows by itself also, and you have this perfect collision and natural creation of the shape. So it's really organic with a few smaller ones, bigger ones, and they all collide so that they fit, I guess. Then I cached that, but I only cached 10 frames. Technically, I could have just cached 1 frame, but for the sake of the video, you can do it whatever you like. But it's important that you end up with the frame you like, which is for me frame number 10. And then we use this simulation here to deform the spheres we created earlier, which I talked about. So we create a sphere with a better topology for rendering, and we create a UV texture for that. And then we subdivide it a bit just to get a smoother shape. We copy it to the same points, and then we point deform it so that the points are deformed like the simulation geometry. So if we look at the simulation geometry and then the point deformed geometry, you can see that they all get deformed according to the points we simulated. And if we look at the peak, I inflated them a little bit more just so they fill all the gaps in between and it looks a bit more natural. So you can just put a small number here and it inflates the whole geometry in the direction of the normal. And after that, we already have the base shape for our render. Besides that, we want to create 2 things. The bigger tendrils here, as you can see in real strawberries, which we do, first of all, we create a mask. You can see I use the direction mask to create this, I guess, angle towards the bottom. And if I'm not wrong, I also use the ambient occlusion to deal with the berries blocking the bottom side of other berries. And what you end up is this mask. Then after I created the mask, I create a normal on the geometry, as you can see. And, oh, this is the wrong one. We want to use this one, the point normals. And from that, I use this pointer angle to lerp between the normal and the negative up vector. So that we end up with this, so that we can use the direction here, the normals, to drive in which direction the bigger hairs or the tendrils go. So we use a connectivity again to split all the geometry, and then for each we do nothing but blast everything but 1 point. So we end up with 1 point for each of the berries, but since on most of the strawberries you don't see a tendril on every berry, we use a random selection node. It's a labs node, so labs random selection, and you can use it to delete random points or according to a specific ratio. And after that, we just add a p-scale attribute, so with a bit of a noise, or a bit of a randomization. So they are all different, a little bit of different sizes. Then we noise the n attribute a little bit so that they all don't exactly grow downward, but as you can see, I just added a bit of noise. And after that, I created 1 tendril. As you can see, I put it in the right direction here. And I resampled it. And after that, I copied it to all of the points. And then there's this guide collide node, which is used for the hair nodes in Houdini. But wait, let me turn this dark so you can see everything. And using this guide collide node, we can wire in our Raspberry, which we create a VDB from, a simple one. You don't need to do extremely high res just for the collision. And together with that, we can have the hairs even collide with the surface, so they don't intersect with the geometry. After that, I smooth it a little bit because I don't want these jagged edges. Then I sweep, and if we turn off the normals, you can see it creates these little shapes of the hair. You can make them thinner or modify them a little bit, but this is just a simple shape I created, which worked for me. And after that, we can send it to Stage to render it. And I think I also exported the curve view attribute, yes, to shade it later on. Now everything that is missing is the little hairs on the big geometry. So on the real Raspberries, you see little, really tiny hairs on top, which create this like fluff on top. And for that, I again also used the mask by feature node, which is really handy for these small things. And if we visualize the mask, you can see that I just created an ambient occlusion mask so that we only grow here where there's actually where we can actually see and where the geometry isn't blocked by other geometry. After that, we remap it a little bit and use a hair gen to create hairs, which are a bit long now. So we use a guide process to create smaller ones. And I even added a little bit of variation. And after that, we can just render it. We'll quickly go over the render setup as well. So we just export all of these three. And for the Raspberry itself, I created a texture in Copernicus, which is here. It's a bit unorganized, to be honest, but it's also really simple. So first of all, I created a noise here. Just a simple fractal noise, which I then remapped. And then I used that, I blended that with two noises, one that is a bit like vertical, as well as one for like little pores. I used that I saw that in a flower tutorial also by Antegma, and I found it really handy for like organic plant-related textures, because they often have these little almost cells, I guess, in comparison, in addition to the colors and slight variations. So I just blended them, and we use this to drive a ramp. If you look at it, it has these really fine details. So you're able to get really close-ups of the Raspberry at the end and have these high quality renders. We export that as a diffuse map for the base color. Then what we also do is we used blended between the vertical and the normal fractal noise as a roughness map, and then we create a height map from the three blended maps. After that, we go to the stage context. And here, if we select the camera, you can see we have a strawberry, which takes a little bit to render, and I have the denoising turned on, as well as the ACES tone mapping for the viewport to see how it might look later. And now we can go over the setup. So we just import everything here, the hair, the fur, and the Raspberry. And then we create the materials for it. So first of all, the Raspberry material, just import the image we exported from Copernicus. Same with the roughness, as well as the normal map. You can remap the roughness if you don't like it, as well as modify. You always need the normal map node between the normal map and the input in the material extended surface. And as you can see the, if we get really close, you can see the details of the pores. Then we quickly go over the tiny hair as well. It's just a simple Kama hair shader. Nothing special here, to be honest. I don't think anything has changed besides the melanin, which we turned down so they don't have a color. And then for the big hair, I just created I used the geometry property value curve view to drive a ramp for the color, which you can see is just this from red to this yellowish color at the tip. And I also used a simple noise to drive the roughness, as you can see, as well as using the height to normal node to create a normal from the noise as well. And besides that, that's it. As you can see, it's a simple stage setup, just the material library, then the material linker to apply all the textures, and a camera, as well as two lights. One is behind and one here as a key light. Technically, you can create a fill here to get rid of this dark shadow, but yeah, that's up to you. I just wanted to show you how you can create a strawberry, and I hope we can see each other again in the next video.